40 starships begin firing nuclear missiles towards the poles of Mars. The fireworks show has begun.
An entire nation dedicated to a common goal, to turn a lifeless rock into a garden.
The missiles take turns, exploding far above the surface in the Martian atmosphere. 2 pulsing suns are created in the skies above the north and south poles of Mars. And so begins the terraforming of Mars. The cold, radioactive, and sterile desert surface is being rehabilitated into its former green self. The temperature is rising, the ice is melting, and the atmosphere thickening, kickstarting a cascading greenhouse effect. Mars is being rebooted. What will grow, and what kinds of creatures will make the planet their home? When will humans take over and launch long-term terraforming missions, such as the building of a magnetosphere and oxygenating and seeding the planet? Or will time start to run out as younger generations become used to living underground in domed settlements, losing their connection to Earth and having no desire to continue the multi-generational terraforming project? The nuclear explosions, the 2 suns, are shining brightly above the poles. This is phase 1 of terraforming Mars. It is the mass extraction of CO2 ice. Mars is so cold because the atmosphere is only 1% of Earth's. It is not enough to capture the heat coming in from the sun. Any liquid water on the surface quickly freezes or evaporates. The low pressure also pulls out all of the oxygen from a human's blood, causing circulatory shutdown within a minute, requiring pressurized suits to survive. The 2 nuclear suns start melting the ice caps. As the CO2 and water in the ice caps melt and turn into gases, it is released into the air, creating a thicker atmosphere. The red planet's temperature begins to rise. Averages go from -60 Celsius, -76 Fahrenheit, to -40. Terraforming is first seen in the warmest regions near the equator, and in the deepest craters and valleys. Liquid water starts appearing on the surface, but freezes at night. As the surface becomes warmer and more CO2 and water melts, thickening the atmosphere, it begins trapping more heat, which melts more CO2 and water, speeding up the terraforming mission. And so it begins, the runaway greenhouse effect. Mars begins to take over, like an advanced artificial intelligence, able to start programming a stronger version of itself. As temperatures in more regions begin to reach 0 Celsius, 32 Fahrenheit, underground ice begins to melt. Liquid water is seeping out of the soil and hills, flowing down carved-out ancient riverbeds and into prehistoric lake craters. As water vapor evaporates into the atmosphere, more clouds begin to form. It is cold at first, with snow and hail, then it begins to rain, starting the water cycle. The red dust covering Mars starts to be washed away. Rivers are flowing, moving slowly because of the lower gravity. Most of Mars starts to get covered with 30 feet, 9 meters of water, recreating the first oceans. 87% of the ancient oceans on Mars have been lost to space. What survived was stored in the polar ice caps. But now, the oceans are returning. When fully terraformed, Mars will have an ocean a mile, 1.6 kilometers deep, covering more than 20% of the planet, with slow-moving monster waves. There will be one giant ocean in the northern hemisphere where it is flat and below average elevation, while in the south, filled with craters and high elevation, there will be dry land. As the atmosphere gets thicker, it begins to block more radiation, solar radiation and cosmic rays that have been sterilizing the surface. The sky is now starting to turn into a light shade of blue. Water is seeping through cracks going deep underground. Any subterranean, ancient Martian bacteria that has survived underground will start growing and spreading. The bacteria starts rising to the surface, where the growing pools of water, thickening atmosphere, and sunlight helps it grow and spread. Bacteria can survive in the vacuum of space and in radiation. Some can even survive for millions of years. If there is no ancient Martian bacteria, then it will be seeded from Earth. These bacteria will be bioengineered, designed to survive in cold, high-radiation environments, and made to grow and spread fast. Once they have established themselves on the planet, they will rapidly adapt and evolve to the local environments, going through 500 generations in a single year. The bacteria will begin to break up rocks, creating soil, paving the way for more complex organisms and plants to survive, from algae, grasses, and moss. Mars is now partially terraformed. Oxygen masks are still needed, but in the lower areas of the southern plains, humans will not need pressure suits. Structures don't need to be built as strong to withstand the pressure, and radiation from space is reduced, so habitats do not need to be buried deep underground. Now begins the multi-generation long projects to terraform Mars completely. The successful development of nuclear fusion on Earth begins to shorten the terraforming timeline. The crater. Rather than terraforming the whole planet, work starts on terraforming a specific location, a deep crater. This is the para-terraforming mission. An entire crater is covered and enclosed. It becomes a transparent dome, turning it into an open, semi-underground Earth. Construction continues on the deep crater floor, where it is shielded from radiation, warm at around 20 Celsius, 68 Fahrenheit, and has a high pressure, allowing for liquid water and not needing pressure suits or pressurized habitats. Crews can only live on the surface for a short amount of time, even in their spaceships, as they are bombarded by solar and cosmic rays which split the nuclei of the atoms in the metal of the spacecraft. This is why humans need to go deep within Mars. Living in the enclosed crater, the climate is controlled, and the atmosphere is geoengineered to be breathable. The red soil is mixed with a glue made out of plants and is baked to make bricks and a 3D printing material. There are open areas for farming plants in the native Martian soil. A bioreactor machine mixes water to clean the soil of the harmful perchlorate, making it ready to use for farming. Liquid water evaporates into the atmosphere of the dome, creating rain. Tunnel diggers are digging into the sides of the crater to create more enclosed, oxygenated habitats. Tunnels will soon connect the crater habitats to more craters, lava tubes, launch pads, and other areas of Mars, creating a subterranean network. Terraforming the entire planet of Mars continues. With its thicker atmosphere, warm climate, flowing rivers and ocean waves, and growing bacteria. Genetically engineering humans advances on Earth, and humanity cures cancer, allowing astronauts to start living in habitats on the surface of Mars with no fear of radiation. Asteroids and comets are redirected, targeting the deserts on Mars. Because there is not enough CO2 on Mars to fully transform the atmosphere, a company is paid to import additional materials to make the atmosphere thicker. Ice and nitrogen asteroids are also harvested for the atmosphere, used to make the soil habitable for growing native plants. Planetary fusion reactors now dot the Martian landscape. Superconducting cables wrap around Mars from north to south and around the equator, passing through the Mariner Valley, just like the primitive undersea internet cables on Earth. An electrical current begins to pulsate and encircle Mars. This is the Solenoid Loop project, built to reboot Mars's magnetic field. Without a natural magnetic field, 100 grams to 2 kilograms of atmosphere needs to be manufactured by settlers every second, as solar winds strip the unprotected atmosphere away into space. Mars had a magnetic field before, but massive asteroids smashing into the surface possibly disrupted the heat flow in the core of the planet, and it began to shut down. So it needs to be rebooted. The cables on the surface wrap around Mars's magnetic inner core. As the nuclear fusion reactors turn on, sending electrical currents through the cables, it begins to create a magnetic field, surrounding the planet and reaching out into space. It starts blocking solar and cosmic radiation and protects the atmosphere from being stripped away into space. As the magnetosphere grows and strengthens, the green glows of auroras begin dancing over the north and south poles of Mars. Now protected by the engineered magnetic field, the atmosphere on Mars starts reaching the final stages of being complete. More nitrogen asteroids are harvested for the atmosphere. It is being re-engineered to lower the carbon dioxide, making the surface habitable for more complex microorganisms, plants, animals, and humans. Tardigrades are the pioneering species on Mars, nature's greatest survivors. They are feeding on bacteria and algae, soaking up carbon dioxide, radiation, heavy metals, and dust, and providing food for larger creatures. Human-made oxygen towers and mass algae farms speed up the process of turning more CO2 into oxygen, as carbon dioxide is made up of 73% oxygen. Genetically engineered plants and trees are being introduced onto the wild surface of Mars. This is the seeding stage of Project Terra. Advanced bioengineered flowering species and insects are seeded. And as more complex organisms are introduced, with selective breeding, the soil and surface becomes more enriched, building the foundation for a more complex biological world to thrive. We do not know where our future technology will lead us, or how human bodies could be bioengineered to survive on Mars, in the end, giving humanity control of its own evolution.